Hello, everyone. Welcome to your webinar series on shaping high-resolution imaging in preclinical research. This is Meena Lakshman, the Scientific Applications Manager, and I will be your moderator for this webinar. Before we start, here's some housekeeping information. As we present this webinar to you, a recording of this webinar will be made available at the end. All lines will be muted for the duration of the webinar. Please use the chat window just in case you have any questions. We do encourage your questions throughout the webinar. However, the questions will be addressed at the end of this presentation. The duration of the presentation is estimated at 45 minutes with 10 to 15 minutes of questions and some updates as we close the presentation. You can also look at this webinar. It will be archived at the website that you see at the very bottom of the screen. And you can also look at upcoming webinars. So today's webinar is on a very exciting topic on the Vivo 3100, which brings me to the introduction of our speaker, Andrew Needles. He is the Senior Manager currently in Product Innovation at VisualSonics, and he currently oversees the Vivo Imaging Systems product line, and his leadership focuses on enhancing overall user experience by delivering on a customer-centric product roadmap. And this will be highlighted in his presentation today. He is an electrical engineer by training and has worked very closely on development of instrumentation used for manufacturing and testing fiber optic components. He does come as a research engineer from Sunnybrook Hospital, and his research focused on using high-frequency ultrasound for imaging blood flow in the microcirculation. So without further ado, I'm going to pass the presenter rights to Andrew. And Andrew, please keep us updated.
Great. Thank you very much, Meena, for the introduction. And it's a pleasure to be joined by so many people online today. Thanks to everyone for taking the time to join in. So as noted, my talk today will focus on the Vivo 3100 platform. This is a new imaging platform for ultra-high frequency ultrasound imaging, recently launched earlier this September at the World Molecular Imaging Congress in Seoul, Korea. I'd like to introduce everyone to the new platform. Here are some images of the system. You can see many of the new aspects of the overall design, namely the touchscreen interface. This has been a lot of work at VisualSonics that we've undertaken over the last several years, and I just want to express from myself and everyone at VisualSonics what a pleasure it is to have the opportunity to speak to you about this new technology and share some of the new exciting results and direction for this new platform. I'll just start off with a few of the key features just to help bring you up to speed with all of the new developments that we have undertaken. The first thing, and really the motivation behind this new platform, was to develop something, an ultrasound technology, that was easy to use and learn. We know that ultrasound for many users requires training and can be very application dependent, and we wanted to develop a system that really helped guide users to quickly get their images and quickly be able to process their data to help expedite their research, ultimately leading to faster results and faster publications. The next element is the modern state-of-the-art design. You can see from some of the images I've showed you the overall change in look and feel to this new system. And much of this has been borrowed from our clinical parent company, Sonocyte, and I'll share a little bit more on that particular topic later on in the webinar. Another big advancement is overall workflow. It's customizable, and I'll get into a little more about the details of how the system can be customized, but ultimately this leads to rapid data acquisition. This is all facilitated by the simple touchscreen interface that is really, again, designed for all user types, not just expert sonographers or expert ultrasound users, all user types that are working within the laboratory environment. On a technical side, we've developed Vivo HD technology. This is a new proprietary algorithm designed specifically for superior image quality, and this technology is enabled on the Vivo 3100 platform. And later on in the webinar, I will show you a number of examples of where Vivo HD technology can help to improve imaging and ultimately the data. We've also developed a number of onboard tutorials, video tutorials. The idea here is that you learn as you go. As you're imaging, you have the opportunity to quickly look into a help area where you can get information, video information on how to perform a particular type of scan for a particular type of application. So all of that is built into the system as an added feature for the Vivo 3100. The transducers themselves are redesigned. They're lightweight, much more ergonomic, and they have improved sensitivity, which leads to better overall imaging depth and image quality. And finally, but not least importantly, the system is much more compact. It's over a 40% reduction in both size and weight relative to previous generations of Vivo technology. So this is a significant change that we feel for many users is important in their laboratory environment where space can often be at a premium. The system itself is highly portable and can be placed into your laboratory with a very small footprint. So where do we start? This is the one-touch imaging interface. When you start up your Vivo 3100 system, this is the screen that you're prompted with. We can see here we are prompted with the options to either go directly to our previously saved studies, to get some help, or to begin with one touch by clicking the application. In this case, we're looking at a 25 megahertz transducer, and we can pick a variety of applications that are appropriate. In this case, we're looking at a number of different rat imaging applications. So with the press of a button, you're quickly brought into the main control panel. Here we can see the touchscreen display and all of the customizable interface. All of these buttons can be dragged and dropped, similar to many tablet-based technologies that are used today in our homes and in the workplace. Many of these buttons can be set up depending on your workflows, and all of them are saved by user type. So every user is logging into the system with a unique ID. All of that user account information is saved, and all of the buttons and placement can be configured to really suit the user's needs. So any particular settings, in this case, on the right-hand side, we've got clip settings, Doppler angle. These are settings that would be appropriate for one user, but perhaps another user is not using those controls very often. Those controls can simply be dragged up into the more controls area and hidden or pulled out again. So all of this interface is, as I say, very intuitive, very customizable, and very approachable. Many people that have seen the system since it's been released, one of their first comments is just how intuitive it is to work your way through the scanning experience, the ultrasound scanning experience on this platform. I'd like to move now into some details about the product, but specifically towards applications. And I'll show you a series of images in the coming slides. Here's a picture, again, of the system. We see on the top of the system the display monitor, the touch screen, all of the high-frequency electronics in the bottom of the ultrasound system. And this just gives you a nice view of the overall system. In terms of applications, there are multiple applications. I won't list them all here, but I will list some of the main ones, and I won't be showing all of them today, but I'll show you what I think are some of the key highlights and some initial images that we've gotten with the new platform. I'll talk a little bit about cardiovascular and cancer imaging, developmental imaging, some abdominal examples. Neurobiology is another application. I don't actually have any examples today. I have one at the end that I will talk a little bit about and where we're going with neuro as well. One thing I do want to highlight is there are transducer-specific applications. So what that means is on the very first touchscreen layout that I showed you, one of the first slides that I showed you today. It's very application dependent in that for a particular transducer, that was a 25 megahertz transducer that was connected. You could see all of the appropriate applications used for that transducer. That then leads into a number of different presets, and they're all specific by animal type and anatomy. So right off the bat, when you start imaging with the system, for a particular transducer, you know the applications that you should be attempting with it. If you don't see your application there, chances are you aren't using the right transducer. You should either be switching or contacting VisualSonics to find out more about other transducer technologies that may be better suited for the application. All of the imaging, all of the success with ultrasound imaging really stems from the choice of transducer. We really wanted to make that very, very apparent right up front as soon as you approach the system, where you need to be starting to get the best possible data. And finally, as I mentioned, in terms of applications, the onboard tutorials and also all of the imaging guides are now built right into the system. So again, for a given application, if you do need help and assistance, you have all of that information there to help guide you through. You're certainly welcome to call us at any time, but when you're in the animal facility, in the lab, you often want the information immediately, and it's right there now at your fingertips. I've got a series of images coming up. Now I'm starting with some vascular imaging, and here I want to highlight the Vivo HD technology. So the first image here on the left-hand side, this is an image taken without Vivo HD of the left common carotid artery in the mouse. And here you can see, same image done with Vivo HD. You can see the striking contrast along the walls of the vessel, really nice delineation of the vessel walls. You can see the carotid and also the branching portion of the carotid towards the right side of the image. So again, here we've got really a beautiful image done at 40 megahertz using Vivo HD technology. Moving on to the next example. On the left-hand side, also a very nice image here on the short axis. This is done without Vivo HD. You can see very nice depicting of the papillary muscles here in the short axis. You can see a lot of the blood flow. What I wanted to illustrate on this slide is, this is a case where this image is taken without any Vivo HD technology. Still a very nice image. Just waiting for some people lines here for a second. Okay. Here we have an image on the right-hand side. What I wanted to point out here, this image is actually done at 30 megahertz, so done with a lower frequency. The reason this is significant is many animal models, often surgical animal models, do benefit from the use of a lower frequency, as there's often scarring or other tissues that need to be imaged. This can cause artifacts and other imaging depth problems. So by using a lower frequency, you can often help alleviate some of those issues. You do lose some resolution, but here's an example where using 30 megahertz as compared to 40 megahertz with Vivo HD still gives us a very, very good image. This is in the short axis again of a mouse heart. We're looking at a very, very small structure here. This is approximately half a centimeter in size, so just a few millimeters in size. Yeah, so again, this image is done in a mouse. All of the images I've shown so far are done in mice. In fact, I believe all of the images I'm showing today are being done in mice. Again, here we are in a mouse looking at the left coronary artery. This is without Vivo HD. You can see here on the right-hand side, using Vivo HD, how the coronary artery, as we're scanning through, this is just done with scanning freehand, just by, you see the coronary artery there come into view. Beautiful long section of that coronary. Again, this is a very, very small vessel, approximately just a few hundred microns in diameter. I'll just let it play around one more time. So again, this is done in the left coronary artery of an adult, healthy adult mouse. Just continuing on with the theme of the coronary artery, this is actually in the same mouse, but here we're looking at the aortic root, the left and right coronary, trying to find these two vessels. This, I'm told by one of our application specialists, is very, very hard to do without the Vivo HD on. You can just see them both come in and out of view, and this really helps with placement then of the Doppler sample volume. You can see you get a very, very nice Doppler waveform of the coronary flow, again, in this adult mouse, and this is all done at 40 megahertz. Just changing applications here, I did want to show you one example of tumor imaging. This is a xenograft tumor from the hind limb of a mouse, looking at blood flow using both color Doppler and 3D power Doppler. You can see the 3D rendering here, looking at blood flow. All of this blood flow can then be quantified using regions of interest to take integration of the blood flow signal to look at changes in that blood flow as a result of different therapies. So some examples here of looking at microcirculation in tumors. Here's some examples of abdominal imaging, again looking in the kidney. As I mentioned, all of these images are taken from adult mice. Here we're getting really nice visualization of blood flow throughout the entire cortex of the animal, of the kidney here. Just let that play one more time. I apologize, we unfortunately have the window washer outside our building right now. Not the best timing. We should have alerted them of our webinar, I guess. Here we are just changing to another organ within the abdomen, looking at hepatic blood flow, really well vascularized here in this liver. Again, this is in an adult mouse. Looking in the pancreas now, you can see both venous and arterial flow here in the pancreas. And now I'm moving to some mouse embryo in this case. We're looking at, this is cardiovascular imaging, lots of blood flow in this embryo. Another example, this is just looking at the embryo. In this case, this is at our highest frequency. This is actually at 48 megahertz in this case. You can see, even just in the B mode image, the really, really bright speckle that comes off the blood in this embryo, and you can see the beating heart and some of the other structures such as the eye. So again, this is just with B mode imaging without any color Doppler. You get really, really nice visualization of the flow patterns just looking at those bright speckle in this embryo. Here we're looking at spinal blood flow. Again, in the embryo, you see that spinal column pattern and the microcirculation there. And one last example, this is some placental flow. So I just wanted to give you really an overview of some initial applications in imaging that we have done. We're continuing to do more and more every day. But I wanted to give you really an overview of what the images look like, particularly using the Vivo HD technology, and really how this improves the overall imaging depth, imaging sensitivity, and image contrast. Beyond Vivo HD, the transducers themselves give us a big improvement in overall imaging performance. And here I'm introducing the MX series of transducers. This is a new line of transducers exclusively for the Vivo 3100. You can see, in this case, this image shows on the left a MX700, which is a 50 megahertz center frequency transducer with frequencies up to 70 megahertz. There's a number of other accessories beyond just the transducers. In this slide, we're showing also the Vivo imaging station. This is a new platform and tablet-based controller that are under development and will be released soon and will be available in conjunction with the Vivo 3100. So coming back to the transducers for a minute, I wanted to show you some examples. I mentioned the MS transducer. This is the older series, our current series of transducer. The MX, which has now just been released. You can see here some of the differences just in the overall ergonomics and shape. So this is a 15 megahertz transducer, our lowest frequency. You can see really the changes in terms of overall size. Something I failed to mention earlier is the actual cable itself is a smaller gauge and thinner and much lighter cable. So for anyone doing hand ultrasound scanning, this is actually, from an ergonomics point of view, quite beneficial. I'll just take you through the different style of transducers. Here we're looking at the MX250 and 250S. Again, a much smaller footprint and much more ergonomic in terms of the ability to hold the transducer towards the tip. Here looking at the MX400 and 550. And finally the MX700, this is our highest frequency transducer. And here you really see the dramatic change in overall look, feel, and size of this transducer relative to the current MS series. Let's just give you an idea of the actual change in the transducer line. And again, this is the MX series that will be exclusive with the Vivo 3100 system. I do want to say a couple words just about customer support. Obviously, this goes without saying that for all our different products, we offer a number of different lines of support. Specifically with the 3100, we do have some of the tools I mentioned built into the platform itself, everything from the video tutorials to the imaging guides. But I encourage you to take advantage of as many different forms of customer support that we offer. Obviously, the webinar that we're doing today is one form of it, but we do offer, always offer on-site training, the university courses in our Toronto and Amsterdam offices. I mentioned the imaging guides and videos. Those videos, I should point out, are actually available to all VisualSonics customers, not just on the 3100. If you'd like to view them on the website, they will be available as well. Some other programs through grant support and our Vivo Ambassador program, which we'll talk about a little bit later, and Mina will share some updates there with you as well. And always online support. I put the website address here for you, visualsonics.com. Please do register on the website, become a user, and take advantage of all the various materials that are on the website today. Just wanted to give a few early testimonials from customers that have had the opportunity to see and do some imaging with the system. These are a few of my favorites. The first one that jumped out at me was the comment about customization being a big advantage for our projects. I think that really is a key point for the 3100 system. And it's really only once you get a chance to see it and use it that you realize how the ability to configure the system and the layout of controls how you like it, and it's how it's suited to your experiment, really becomes a big benefit without having to navigate throughout the harder touch button keyboard. For some people, they do like a keyboard, and I think there's value in that as well. But the ability to do the customization of the 3100 is a big advantage. So that's one of the comments from one of our early customers to view the system. Another individual stated that they could easily see going from 10 minutes to 5 minutes in terms of their imaging time due to this customization and the ability to save the ideal settings right on the system. So I thought that was significant and worth sharing with everybody. In terms of just the design, someone else commented they just thought it was very much in line with everyday products that they're used to in their environment. touchscreens and tablets have become so ubiquitous in our everyday lives that we thought it made sense for an ultrasound platform to take advantage of some of those same technology. And finally, just in terms of the Doppler waveforms, this is from one of our customers who also uses clinical systems. He thought that the Doppler waveforms were beautiful, and that, in fact, his comment was that they were better than on his clinical machine. So I thought that was quite a compliment, and I was really pleased to hear that. So a lot of hard work had gone into making these images, particularly the Doppler imaging, as good as we possibly could. So those are a few thoughts, and as we continue forward with the Vivo 3100, I'm sure many of you will get the opportunity, hopefully, to see the system at some point in the future, and perhaps you can give us some of your own feedback as well. I do want to take a few moments to talk not just about the Vivo 3100, but where it sits relative to all of our different products. We've spent the last 16 months really expanding our product portfolio, and we now have a product ladder of systems, starting with our Vivo 1100 platform. This was a platform that was launched earlier this year. It's really designed as a starter cardiovascular imaging system, and it's really a fantastic system for people that are getting themselves introduced to ultrasound imaging. The Vivo 2100, many of you know and are using today. This is really has been our flagship system for a number of years, and the 3100, as we're announcing and showing you today, has become really the latest and most current design. But I just want to make clear for everybody that we will continue to support all of these products and offer customers the opportunities, if they begin working with one of the technologies, through different upgrade programs, to be able to move their way through this product ladder, if that so interests them. In terms of the features, we can see that in terms of axial resolution, all systems do very, very well. They're all actually equivalent in that respect. In terms of lateral resolution, there are some, basically the 2100 and 3100 are equivalent. They are an improvement over the 1100. And really where things start to differentiate away from the 1100, the 2100 has a number of different imaging processing features, multifocusing, line density, synthetic aperture, and then many of the new features that we discussed already do apply to the 3100. The Vivo HD, the MX series transducers, the customizable workflow, built-in applications, which really extends to presets, videos, and imaging guides right on the system, and then just the overall size and weight of the 3100 is another significant key feature. So this just gives you a sense of how all the products compare to one another, and this, as I mentioned, will be our product line moving forward. I won't go through every feature here, but I just wanted to again stress some of the distinctions between the 1100. In particular, the 1100 is a cardiovascular system. It has really all of the tools required to do the general cardiovascular exam. This includes things like B mode, M mode, pulse wave Doppler, color Doppler, all of the cardiac measurements, the LV trace, and all of the physiological monitoring. The 2100, I won't go through all of that. I think many people are probably familiar with that already. But I just wanted to show that the Vivo 3100 supports all of these same modes that are found on the 2100, as well as some new features that are listed here. And again, most of these we've talked about already. You'll see towards the bottom some things that I've marked as future. These are new technologies that we are developing and will be releasing in the coming years, coming months and years with the Vivo 3100. And I'll just show you a snapshot of that and how we envision our development roadmap for this system. We do envision that in early 2015, we've made provisions for what I call a maintenance release. This may be updating, depending on feedback that comes back from early customers that are using the platform. We have allotted some time to make some small updates to the system if required. Other features that are coming, though, 4D imaging. This is essentially our EKV technology, a retrospective based approach for imaging, where we can stitch together multiple cycles, heart cycles. By doing this in 3D, we can essentially create a 4D image on the Vivo 3100 platform. Vivo Lab is an environment, an offline workstation environment for viewing data and doing analysis, and we are working on methods of streaming all of the information from the Vivo 3100 into the offline workstation environment more seamless, and that's something that is on the development roadmap for 2015. Other technologies include automatic LV tracing, so getting quick and accurate cardiac parameters, things such as cardiac output, stroke volume, all of those types of metrics, with an algorithm that would automatically trace the left ventricle in the image. So this would, again, really lead to increased throughput, not just on the imaging, but really on the analysis side of things as well. And finally, another benefit of doing 4D imaging is the ability then to do strain measurements in 3D. And there's new tools that we are looking at and developing specifically for that. The final point I'd like to make, and I've listed here, is clinical projects. I'll just switch to my next slide to talk about this specifically. You can see here the export system that comes from our parent company, Sonosite. So we are a wholly owned subsidiary of Sonosite, and Sonosite is part of the group of FUJIFILM companies. So we do have clinical partners that we're part of a large clinical organization now. And really the point I wanted to make today is that the Vivo 3100, while it is a preclinical product, it definitely puts us on the path towards moving high-frequency technology into the clinical, not just the clinical space, but also clinical research space. So you can see many of the parallels in terms of the design in this family of products here between the 3100 and also seeing it next to the Sonosite export system. You can see some of the parallels. And there will be more to come on this, but I just wanted to make people aware today that our goal is to, over the coming years, to develop clinical technologies and to take high-frequency technologies into the clinic. That summarizes the 3100, and I just to maybe take a moment to stop and say that it's been an exciting last few years developing this new technology, and it's such a pleasure to finally have it on the market and to be sharing it with all of you today. So we'll take some questions at the end. Before we get there, I wanted to take the opportunity today to update you on some other products that we're developing, not specific to the 3100, but just some other products in general and other news. So I'll just go through this as well. User management mode is actually very related to the 3100. This is a software mode that essentially, as I mentioned, comes with the 3100. It comes with the 2100 as well, but a user would actually have to go in and set it up. The whole 3100 platform is based off the user management mode. Everyone is a user in the system. If you're not a user, you're logging in as a guest. And that really, again, speaks to the customization and the ability to save all of those settings. But essentially, user management mode, which also leads into another feature called usage log, allows for the creation of user accounts, the customization of settings, improved data organization, sharing, and security. So it's really ideal for core facilities or places where there's multiple users accessing the system. Everyone's got login information, log in and log out, personalized preferences and presets, and it enables the use of usage log, which is a time tracking software for system usage. This is a paid feature and is an extra paid feature, but it is all enabled by the user management mode. So again, it is available on the 2100, and also on the 3100, and is much more streamlined, I would say, on that platform, as it's set up ready to go right out of the box on the 3100. I also mentioned Vivo Lab earlier. This is just to illustrate how this platform works. All of the 1100 and beyond, 1100, 2100, 3100 series are compatible with the Vivo Lab workstation software. Many of you will know this software environment as our PC workstation software. Vivo Lab really is replacing and rebranding, so from the customer side, there's no need to change dongles or anything like that. It's just really a software update that would, again, rebrand it and also make the software compatible with all different types of image data. So when you're in the Vivo Lab, any image or CineLoop will be identified, so they have a unique identifier saying which system it actually came from. So you'll know if it's an 1100, 2100, 3100, etc. And this schematic just illustrates all of that. All of the data from all the different products within the ladder. I should also point out our Vivo Laser platform, which is our photoacoustic system that runs with Vivo 2100. All of that data can be worked with and analyzed in the Vivo Lab workstation. I'd also like to announce Vivo Strain. We've made an update. This is Vivo Strain 2.0. Very, very close to releasing this, and this will actually be part of the next Vivo Lab release, which is coming out in the next few weeks. We'll be talking more about this at AHA conference later in November. And this is a new update with a number of expanded features, revised measurements, and revised measurement exports, selection of multiple cycles, workflow improvements, more calculations, more optimization to the algorithm, the tracking algorithm. You can actually load multiple data sets now, which is a huge advantage. An undo functionality, which is something that was many people had requested. There's a number of other features, and if you have questions specific about Vivo Strain 2.0, I'd be happy to take those offline as well. It's my pleasure to announce to everyone a partnership with a company called Invicro. Hopefully some of you have heard of this company before. We have been working with Invicro over the last several months to develop a new add-on to their IPAX environment. We've developed something called VisualSonics IPAX. This is a new innovative data management solution for VisualSonics users. So VisualSonics users now have the ability through the VisualSonics IPAX module to access all of their study data and archive it in the cloud or on a local network. And the IPAX environment really allows streamlined data management and mining and reporting, the finding of data by using powerful query tools. You can share data with internal and external collaborators. You can do this securely. You can do it in real time. And you can organize and make more accessible all of the data that's within the VisualSonics Vivo Lab environment. You can organize that and make it more accessible. And all of and not just the data, but also all of the associated analysis data. So for example, as you're making measurements in your Vivo Lab environment, all of that could be being stored in the cloud through IPAX, and as those changes are made, all of that information is passed on. And all of that can actually be tracked. There is the ability with IPAX to generate custom reports for QA and QC needs, but also just for general presentation needs. So a very powerful platform. I would say more to come on this, but I just wanted to make the announcement today that we are partnering with Invicro as our partner now for data management solutions for VisualSonics data. Finally, and last but not least, I wanted to say a few words about our Vivo Laser photoacoustic platform. We continue to develop and innovate in the area of photoacoustics as well as the area of ultrasound. And these are some new tools designed specifically for multiplexing of different data, both endogenous and molecular and contrast information, and quantifying that signal. So some new tools that are available to all Vivo Laser photoacoustics customers. Here's an example of spectral unmixing, some new algorithms that have been developed. In this particular example, we're looking at separating melanin from blood signals. This is an example of an endogenous signal, but all of this can be applied to contrast agents as well, which leads into the next image, of biodistribution of these gold nanoparticles, gold nanorods specifically in this E12 embryo, the ability to spectrally unmix and isolate these different signals and look at kinetic imaging, the distribution of these agents over time is now enabled through the spectral unmixing as well. And some other tools for general image processing, a background subtraction algorithm that does a very good job of helping, again, isolate these contrast signals. In this case, we're looking at an apoptosis marker called PSView. This is done in a xenograft tumor. So new examples of software that is available. Please do contact us if you'd like to find out more, and we can certainly talk to you about getting your software updated with some of these new tools for the Vivo laser platform. Some other prototype software that's under development. This is a new light delivery table specifically for getting better depth sensitivity within the image. This is also a rotational compounding stage. This is an apparatus for getting better directional sensitivity, specifically in this case looking at microvascular imaging, but can lead to overall image improvements. And finally, a new LZ201 transducer. This is the example of neurobiology I was talking about earlier. This is looking at brain imaging and its pathologies. Here we can see depiction of some blood flow in the brain. This is looking again in an adult mouse brain with the skull intact, and you're seeing right through the skull looking at all of that blood flow. So again, just to clarify, this is our Vivo laser platform. This is a separate technology from the 3100. This is specifically for photoacoustic imaging, and I did just want to give a few updates while I had many people here today about some of the new and exciting things that are being developed in both software and in hardware to improve and push this technology further. So with that, I would open the floor up to any questions, and I do appreciate everyone taking the time today. Hopefully I've given you a sense of not just the 3100, I really wanted to highlight the 3100, but also give you an update just on our overall product portfolio and how all of these different technologies work together. So again, thanks to everyone for joining in. Mina, I'll pass things back to you.
Right, thank you, Andrew. That was very interesting, very streamlined workflow, customizable, and modern design, and to help facilitate a really ultimate and preclinical imaging experience here. So there are questions coming through. I'm going to take a few right now before we go into some follow-up updates at the end of the session. The questions lie alongside of the transducer, Andrew. Does the MS transducer and MX transducers, do they operate differently? Would you like to comment on that?
I would say from an overall ultrasound imaging point of view, they're similar in the sense that they are high-frequency transducers. So in that respect, they're very distinct from what's offered on many clinical lower-frequency systems. So they are, in that sense, they are derived from a similar technology, and they're part of a family of transducers now. So where the distinctions come are some of the things I mentioned, namely the overall size, feel, weight, and also some improvements we've made really to the actual transducer fabrication and the materials, the piezoelectric materials, to improve sensitivity. So are they vastly different? No, but they are, I would say, there's a significant enough difference that we do identify the MX series now as a new line of transducers.
Absolutely. So along the lines of actually the touchscreen interface that you talked about, are they, can we use nitrile and latex gloves? I've used them, and generally we can. And the touchscreen is therefore durable, because gel, that's one of the things. So can we clean it off? Is there any specific instructions with respect to cleaning off this touchscreen now that it is more digital? And
right. We specifically designed the touchscreen with all of these considerations in mind. So in regards to the gloves, all of our applications people typically use gloves when they're imaging, and they continue to do so using the touchscreen interface. So in that regard, it's fully compatible with any type of glove. The image itself, if someone really doesn't want to touch it because for whatever reasons if there's perhaps a particular type of glove that may be thick or is not nitrile or latex, there is always the opportunity to actually use a typical USB mount. I mean, there's USB ports on the system, so someone could do that if they really required, but typically we are imaging with gloves all the time. And as far as cleaning it, we recommend the similar type of what's the word I'm looking for, the cleaning materials that are used on the Vivo 2100 today. So we are actually just in the process of putting together a small technical note on this, but it would essentially be something like a cabbie wipe or tea spray that would be used typically, and that would be the idea. So the touchscreen was specifically designed with that intention. There's also a number of other products. We mentioned I mentioned the Sonosite export system. They've also got a number of different materials that are listed on their website, and we're actually speaking with the folks at Sonosite about those materials and updating our list as well. So I would say if that's, there will be more information specifically on those specifications.
Right.
But the idea is that, yes, all of the touchscreen can be cleaned just as the 2100 or any other ultrasound platform would be.
Okay. No, that's, I mean, that way we know that in terms of durability and usability, there is no change in that respect. Also, with respect to the product lineup that you showed, I mean, some of the questions that are coming through, there are those who are on the 2100, those that, if the interest of 3100 is there, what's the upgrade path? Is there a path for them, whether it be 2100 to 3100, those who are on the laser to the 3100? These are questions. Could you give us an overall path that you have in place?
At this point, just to respect, I'll handle the Vivo laser portion first. The Vivo laser, going forward, we would like to treat as a separate product line, and we will continue to support that and develop the Vivo laser, which for people who aren't familiar, is essentially a Vivo 2100 system coupled with a laser source for doing photoacoustic imaging. We will continue to support that. At this point, the Vivo 3100 is not compatible with photoacoustic technology. Our intention is that one day it will be, but we're working through all of the different design considerations and roadmap planning. So what I wanted to give you a sense of today is for 2015, some of the key features that we are developing purely on the ultrasound side. And as I say, longer term, we would like to have photoacoustics enabled with the 3100, but at this point, we will keep pushing and advancing the technology on the Vivo laser platform with a number of these new initiatives that I showed you that are already in the works. As far as other systems, 1100, 2100, all of those systems, we will support different upgrade paths around that. I would say if people have specific questions about that, I saw maybe there's probably other questions I'm sure about actual pricing, which I would prefer to defer that to our local area managers who can directly follow up and talk about all those different options. So I would encourage people to contact us. Probably the easiest is through info@visualsonics.com. People are also free to contact me. If perhaps we could put my email up in the chat if people want to. They're more than happy to discuss with me, and we can have a specific conversation about the current configuration of the system that the user is running, as well as what they'd like to go to. I would say every situation is unique and requires a separate discussion.
Absolutely. Now, the other feature on the 3100 that you mentioned was the HD technology. Right. And this technology was described in B mode, or the brightness mode. How do you see the advantages of HD in the modes like contrast, and how can that be leveraged for users that are with B mode and contrast?
Just to clarify, and perhaps I should have done this earlier, Vivo HD technology is really an image speckle reduction algorithm that's developed specifically for B mode, because that's typically where you get speckle in your images. Things like contrast, we support other techniques, things like MIP imaging or our Vivo CQ analysis package. I would say there, speckle reduction is less critical. So it's really more a technology that's designed for anatomical imaging, looking for small structures. I showed you those examples of the coronary artery. Very, very hard to find at times, but the Vivo HD does help. So again, the Vivo HD at this point is a B mode technology, and if there were applications where it could be used in other areas, we would use it. We just felt that it had the most benefit, really the most applicability to B mode imaging specifically.
And that's perfect timing with the Vivo Strain 2.0 as well.
Right, right.
Awesome. So as Andrew mentioned, anything with regards to the product letter and how you'd like to see the price points, these can be deferred to your local representatives. That will show up a contact information through the website. Also, Andrew will be providing his contact information through the chat. And this should bring us to the one last question. With respect to recent purchase on the 2100, and will HD technology be available on the 2100 system, Andrew?
There was a number of optimizations we had to do specifically to develop HD that were specific to the Vivo 3100 hardware. So at this point, we don't have any plans to release it on the 2100. It will be strictly on the 3100. But for this particular individual asking the question, again, I'd be happy to talk about some of the applications. And I think even on the 3100, the Vivo HD, it does give a lot of benefit, but I think it's not something that the user is forced into using either. They do have the option to use a non-speckle reduced algorithm. So I think on the 2100, it won't have it. But that being said, perhaps if this individual wants to contact me, we could discuss more about their applications and how they could, perhaps using other methods even of scanning, optimizing image plane, things like that, get better results with the 2100 that they're getting today. But again, 3100 will be Vivo HD will be exclusive to the Vivo 3100 technology.
Absolutely. All right. So we touched upon questions, the interesting questions that came through with respect to streamlined and customizable workflow, onboard tutorials, which we did not show any images here as requested by one of the questions, but we are more than happy to address it through a WebEx or even have you a chance to come and touch and feel the system to see how these tutorials work. One of the questions, the next set of questions was on the Vivo HD technology. And the pricing. Also, the question on the transducers that we just addressed. One question about the cable length of these transducers. Are they similar? Are they longer? That's one of the questions here.
They are similar to our current style. I would say it's something at with high frequency imaging. Cable length is actually a critical parameter, and a lot of that we've optimized specific to frequencies. So cable lengths are similar to what people are used to their MS transducers today.
But it's more flexible than what it was with
definitely
MS.
Yeah, it's a smaller gauge, definitely more flexible, and definitely lighter weight.
Absolutely. The last part, some questions on your other products, including laser. The rotational PA has piqued some interest. Is the rotational PA imaging tomography?
It is a form of tomography, because essentially what that imaging stage is doing, if I can just, perhaps I'll just back up here. So here it is. So this imaging stage or gantry, for lack of a better term, would rotate through a motorized controller and acquire a series of images. So this image of this kidney is actually a compounding. It's rotational RCI imaging, rotational compound imaging is a combination of many, many different angular planes. And this gives the added benefit of being more sensitive to multiple directions. It helps what's known as the visibility condition in photoacoustic imaging by improving your overall aperture, even if it's done, essentially it's done synthetically here by composing a number of different image planes. You can get a more sensitive and more highly resolved image. So yes, it is a form of tomography.
And is that a 3D data set?
This image we're looking at here now it's a 2D image plane because it's a combination, but it can be collected as a 3D data set. So the trade-off, of course, is imaging time and number of planes. The more angles you take, the more wavelengths you take, the more steps you take in the out-of-plane direction here, so that all can be built up into a 3D data set.
Right, this gives a really overall impression, at least in the image that you have of the kidney.
But this is a 2D image we're looking at right here.
All right. In terms of applications between the MS and MX transducers, I'm switching between the 3100 and the laser. Interesting questions coming through. Are there any differences in applications? I mean, obviously, this is going to look at micro-targets and better delineation of margins, including vascular margins or tumor margins, for that matter. Do you agree that that will be a highlight of the two different transducers?
I think there are more applications that we're going to uncover, but I think we still don't know what we don't know yet. I think certainly with the MX series, as we start to image new things using Vivo HD, we may find things that we don't see already. But I don't want to again paint our current technology in a bad light, because I really don't think it is. I think that the Vivo 2100 today can do a very, very good job and has a wealth of applications. I think the MX series, what it really does is it helps expand those current applications. It also helps expand workflow in ergonomics as well. So at this point, I think there's similar applications between the two, but let's see what else we find out, and we can certainly give more updates on that.
All right. Thank you, everyone, for your questions. We are going to slightly move towards the end, and there are many questions coming through. We will send it to Andrew and work our way in answering these questions. And like Andrew mentioned, anything with respect to pricing, he or your local representative will be available to address them. Moving on to the next slide, just some follow-up questions. If you are unaware, we are going to be at the American Heart Association in Chicago next month. You are invited. If you haven't received this invitation, please make sure that you contact us on our website, www.visualsonics.com. If you have not heard from us about our travel awards, it is up on our website as well. It will be one of your, when you do enter our website, you'll see that as one of our splash pages. And that should provide you some opportunity to travel and present your data. This will be data on the Vivo imaging products. All right. More news on questions that you may have from the Vivo 3100. Vivo 3100 web page is available. There is a link in blue for you to click on if you download this presentation. Also, just one more click, the customer support. If you have any questions or feedback, please make sure you go onto our website on the support tab. There are different ways that we can support you. All of the 3100 information is also available on the brochure, which is downloadable, as you can see in the icon on the web page. For those of you at the funding stage right now, or writing your funding, I've put some of the icons from all over the world, whether you be in the UK or in Australia, in the United States or in Canada, and also if you have affiliations with any of the associations or foundations, we do provide a support, the VSI grant support. This is the worksheet that we do send with you, and we work very closely with you to identify how you can justify the need for a Vivo product line, imaging product line, and this is available to you. So use the customer support tab to request for this kind of support for your funding. If you are interested in showing your expertise, either with the Vivo 3100, the 2100, 1100, or the laser imaging platforms, you will become a part of the Vivo Ambassador Program. You just have to click on the link that we have on this page for you to contact me, mlakshman@visualsonics.com. Also, we do have opportunities for you to publish video publications through the Journal of Visualized Experiments. This is a partnership that we have with Jove. You are seeing the Vivo Young Investigator Award was recently done for WIMIC and now available, those in the cardiology and cardiovascular biology research. And will be presented at the VisualSonics VIP event at the American Association Conference. All right. Last but not the least, please tune in for the November event on diabetes and cancer with a focus on ultrasound imaging of atherosclerosis and its progression. We will send you invitation for this webinar, and this brings me to the end of today's presentation and news and updates. We look forward to seeing you soon in November, and also look forward to all of your questions with the Vivo 3100 imaging platform and the rest of our product line. Thank you all. Ciao for now.